Hey folks, welcome to week 3 of DMD250, Intro to Data Visualization. Alright, let's take a look at what we're doing this week. We are going to continue along with our overview of the history of data visualization. Last week we did part 1. This week we are going to go over part 2. And then from that overview of all the various areas of history that play into the development of data visualization, you are going to choose an area that you are most interested in to do further research on and to learn more about. And that's going to go right into our project 2, research and inquiry. And just to mention again, I know this is project 2 and it's our first project, but trust me, it makes sense in the timeline. You will see. Anywho, so we're also going to go over part 1 of the research and inquiry project because that's going to be your homework. Once we finish going through the second part of the history of data visualization, you're going to get working on part 1 of the project. So let's dive into part 2 of our history, and then we'll take a look at the project itself. Okay, so last time we went from 1786 to 1917 and we covered these top areas of history here. And of course, just to remind you, data visualization as an area of practice and study did not sort of come into being fully formed. Most areas of design do not. And so they become an amalgam of a variety of occurrences and experiences over time that led to them becoming what they are today. And so as we went through some of these earlier areas, you see that some of them are specific people, like Florence Nightingale and William Playfair, and others are artistic movements, such as modular design elements from Russian constructivism and Italian futurism, or de style. So either way, we've got 3 individuals, Playfair, Nightingale, and Du Bois, and then a few artistic movements. Now we're moving into 1919, which is really just a couple of years later from where we left off. And we're going to talk about these areas: the founding of the Bauhaus, which is both a school and an artistic movement and speaks to a specific person, which we'll look at, the isotype picture language, the international typographic style, and then 2 specific people who you can really call sort of the founders of data visualization: John Wilder Tukey and Edward Tufte. All right, let's get rolling. Okay, so after we came out of those artistic movements, or even roughly at the same time that we're talking about Russian constructivism and Italian futurism and de style, a art school, unlike any other art school at the time, came into being. So the Bauhaus was a German art school that was in operation only from 1919 to 1933. It did not exist for a very long time. Unfortunately, its existence kind of overlapped with the rise of the Nazi movement in Germany, and let's just say the Nazis were not particularly happy with what they were trying to accomplish in the Bauhaus. So prior to the founding of the Bauhaus, most artists and artisans, if they wanted to get into a particular area of trade, if you wanted to become a furniture designer or an architect or a painter or a sculptor or something like that, you would find a master in that area, somebody who was very well experienced, had been doing it for a long time, and you would ask to apprentice with them. And it would be sort of an apprentice and master situation where you would work for them starting at a young age. They would train you, you would do a whole bunch of things for them, and in the process, learn how to yourself become that expert over a very long period of time, many, many years. And so the whole apprentice system is really what kind of predated this through much of Europe and all over the world. And so while there were certainly art schools in existence, they tended to focus on one area, a school to learn how to paint, for example. The Bauhaus did something completely different. The Bauhaus decided that they were going to combine crafts, arts and crafts, things like building furniture and things like that, design, everything from architectural design to interior design to graphic design, and fine arts like painting and sculpting, and combined them all into one curriculum. And the concept was that students would, in their first year, they would sample a little bit of everything. They would try a little bit of sculpting and a little bit of furniture building and a little bit of painting and so on and so forth. And in that way, they would spend their first year at the school trying to decide what they were truly most interested in by being exposed to a wide variety of things. Now, if this process sounds familiar to you, it's because that is the exact same educational process that today is used by vocational and technical schools in the United States and all over the world, as well as a lot of art and design schools such as the Rhode Island School of Design and the Massachusetts School of Art and Design. They use the Bauhaus method of teaching. And it was founded by the Bauhaus, most specifically by this gentleman over here on the right, Walter Gropius. He had the idea of creating a total work of art in which all different types of art forms, including architecture, could all be brought together in an academic environment. And so you could learn a little bit of everything and then choose to specialize in one area for the remaining time you had in school, for your remaining 3 years or whatever that might be. The Bauhaus also was important for developing a specific type of visual style. So not only did they have an academic style of teaching and a way of creating curriculum for students to learn from, but they had a specific type of style of design that they came up with. And this was very influential to modern artists, modernist architecture and art, design, and architectural education. The Bauhaus had a profound influence on the subsequent development in art, architecture, and graphic design, as well as interior design, industrial design, and typography. Now, the school unfortunately closed in 1933 because they were under a lot of pressure and threats from the Nazi regime, and they actually had to move to 2 locations. They had their original building, and then they moved to another location, trying to, outsmart the Nazis, as it were. And it didn't work. They unfortunately caught up with them, and they were seen as sort of the center of communist intellectualism, which the Nazis didn't take too kindly to. The Bauhaus sought to level the distinction between the fine arts and the applied arts, and to really reunite creativity and manufacturing, and fashioned itself as a kind of craftsman's guild. And that sort of hands-on, almost blue-collar approach to art and design and architecture really became the foundation for so many schools all over the planet. And so the idea, even though it was short-lived in its origin, only from 1919 to 1933, really extended itself well beyond the physical existence of the Bauhaus. And Gropius was really at the center of it. Now, aside from his idea of this innovative curriculum and the styles that it fostered, Gropius was also very well known for bringing in accomplished artists and designers to teach at the school, which lent itself to a lot of its success. This here is an interesting portrait of Walter Gropius done in the Bauhaus style of painting or illustration at this particular time. So you can see that it has a lot in common with a couple of the previous art movements we looked at, De Style and Russian Constructivism, in that it used sort of flat, restricted color palettes, geometric shapes, clean lines, simple typography, interesting angles. All of these choices had a lot in common with some of those other art styles that happened either before the Bauhaus or even roughly at the same time as the Bauhaus. And it's kind of funny that this is a portrait of Gropius done in that particular style. His whole hand on the side of his face thing with his fingers up by his eye is kind of his general pose. You see him in a lot, and so this illustration of him is done to replicate that, which is kind of funny. This was the original building for the Bauhaus. Really beautiful building, and it was constructed, of course, in a style that was in keeping with their aesthetic for architecture. You can see even the typography on the side of the building adheres to that kind of a look. This is a poster done in the Bauhaus style, again with the limited color palette, the flat colors, the geometric shapes. What I like about this one is it also introduces the concept of transparency of shape. You can see through them because they are somewhat translucent, and you can see the other shapes behind it. Lots of arrows and lines. And so like the other artistic styles we looked at, while the Bauhaus wasn't directly involved in the development of data visualization, you can see that a lot of the visual vocabulary that data visualization later adopted came from the Bauhaus or was influenced by the Bauhaus. Here's another poster done in the Bauhaus style. And then here is a poster showing a cross-section of an architectural drawing about a talk about the Bauhaus and German architecture. There's a lot of the snake eating its own tail going on here, but it really shows off a lot of it. And what I like about this example is that you can really see the influence of this style really showing up here with the rectangles and squares and the limited color palette with the thick black outlines. So, you know, a lot of these artistic styles and movements, they obviously don't happen in a vacuum. They are influenced by each other, and so you can sort of see where those lines blur between them. Okay, the next thing we're going to look at is the development of the isotype picture language. Isotype stands for International System of Typographic Picture Education. What it is, it's a method of showing social, technological, biological, and historical connections in pictorial form. And it is a library of pictograms, standardized and abstracted pictorial symbols to represent social scientific data with specific guidelines on how to combine the identical figures using serial repetition. So it was a way in which to use pictograms, and pictograms, of course, date all the way back to prehistoric times when, you know, early man was using basic shapes to communicate on cave walls. And it standardized the representation of these pictograms, not only for easy understanding and quick readability, but also to have them represent a numeric and data-based value, so that the outline or the pictogram of one person could represent 100 people. And then if you were to line up 10 of those little pictograms, well, then you have 1,000 people. And so this is really where art and design starts to make that very purposeful movement into data visualization. It started out back with Playfair and his charts and graphs and his pie chart, and all of the beautiful data visualizations done by Du Bois and his students, and of course the Rose diagram and how it told a very compelling narrative as constructed by Florence Nightingale. But now each of those were individual efforts that were done very specifically for singular purposes. But here, with the isotype picture language, the effort was to take these pictograms, these representational shapes, and then assign numeric values to them and make them very recognizable. So this whole system was developed in Vienna, Switzerland, between 1925 and 1934. And the director of the museum where it was developed, Otto Neuwirth, who you can see on the right here, he was the initiator and chief theorist of this, meaning he didn't develop it, but he came up with the idea for it. He thought it was a really progressive idea that could push forward the idea of visual representation. And so he hired Gerd Ernst, who as the artist and designer, to actually come up with the graphics and his ideas. So he worked closely with Ernst. So, Neuwirth was the idea person, Ernst was the technical person, and they put it together. So his goal, as stated, was to represent social facts pictorially and numerically, and so to bring sort of dead statistics to life by making them visually attractive and memorable. Now that statement sounds a lot like the purpose of data visualization, doesn't it? And so he really took the pie chart and the bar graph idea and pushed it much further with these visual representations. The museum had a catchphrase was, "To remember simplified pictures is better than to forget accurate figures." And it's a really interesting point. So let's take a look at it. And so here is some pages from the book that they developed. Now, of course, one of the initial applications for this library of pictograms was for road travel. The automobile was a new and exciting bit of transportation, and people were falling in love with the automobile. And of course, as a result, you need road signs, you need graphics on the road themselves, you need to be able to traverse different roads and ways of getting around. And so the signage system and the wayfinding system for car travel relied heavily on this. And so you can see some early examples of this. Now we take these for granted. The way pictograms and arrows and symbols work in driving is so uniform now that even if you don't speak the language of a given country, you can hop in a car in most countries and find your way around just by following the signage and the wayfinding system. And this is all thanks to the isotype picture language. Here's some more inside the book, and you can see these are silhouetted pictograms of various recognizable animals or biological things. We have people over here represented. Now, I will say as we get into this, and you have to pay attention to the time frame that this was developed in, right? This was developed between 1925 and 1934. There are definitely some, what we would consider today, stereotypical representations of people from countries around the world within the isotype picture language. And so that certainly makes this a dated system, and maybe some of the representations are not something we would want to use today, but simply the idea of representing people and quantities of people and types of people as pictograms as well as animals and non-living objects as well. That does have a lot of value that starts here. Just pay attention to the stereotypes. Okay, so these, of course, are the types of pictograms that were inside the isotype picture language, many of which are still recognizable and usable today, right? The knife and fork. We see this all over the place. If you see that on a highway sign, well, you must be coming up to where you can find some restaurants, right? If you see the light bulb sign, well, then there's some electricity going on, right? If you were to see this telephone, even though this is a very old-fashioned looking telephone, even today, when telephones don't look anything like this anymore, we still know that's a telephone. The visual vocabulary that was established in the isotype picture language is so embedded into our societal subconscious on a worldwide level that even if the representation is no longer relevant from a current standing in terms of time, we just almost know subconsciously what it is, right? If you were to, look at these two people in hospital bed, well, this one person in two hospital beds, standing next to a pictogram of a nurse. Nurses don't dress like this anymore. Hospital beds don't look like this anymore. And yet we are very clear that that is a nurse standing with a patient in a hospital. So a lot of these have become sort of the standard representation of things, even if the actual things have changed. Now, this is where we get into a lot of stereotypes, but I do want to show you how their ability to represent data was used here. So you have these pictograms representing different types of people from different countries. So up here, these pictograms of people with the hat on, those are people from the USSR, which of course is the former Soviet Union, now Russia. The people who are in yellow wearing the triangular hats, those are people from China. And yes, that is a terrible stereotype that they are yellow and they are wearing the sort of hats that would be worn in rice fields for harvesting. That obviously does not make up all Chinese people, so we recognize it's a terrible stereotype. But at the same time, the idea of using pictograms to represent numerical values of people and doing it comparatively in an overall chart is a really helpful tool. People from Arab nations are represented as sort of brown people wearing turbans, and yes, again, that's a terrible stereotype, but we recognize that, but pay more attention to the fact of how these pictograms are used to represent quantitative data. Okay, next we move on to the International Typographic Style. So while Neuwirth and Gernst were sort of standardizing pictograms, the International Typographic Style standardized modern typography. Now, typography, similar to data visualization, is an area of design that did not start out as being called typography. First, letter forms were carved into stone on the side of official buildings or churches so that people could recognize what they were. And then simple printing presses were developed in Egypt and in other places so that people who could afford these printed artifacts learned how to read and created letter alphabets and so on. And then Gutenberg's press was invented where large quantities of printed materials could be distributed to larger quantities of people, and therefore the literacy rate went up because more and more people, even if they didn't have a lot of money, had things they could learn to read from. And so printing and using letter forms and alphabets and all that, this pre-exists this obviously for a very long time. But there was no real sort of standardized typography, or if there was, it was sort of hit or miss. And so the International Typographic Style, which is also known as the Swiss style, is a graphic design style developed in Switzerland, hence the name, in the 1950s, and it really wanted to emphasize sort of cleanliness, readability, and objectivity. It really wanted to take letter forms and move them into the future and make them clean and very modern looking and easy to read and understand. So similar to Italian Futurism, this was a design movement that really was looking to the future. Now, as you probably know now, just by looking at your computer and going through the list of fonts that are on your computer, not all fonts that we have today are clean and modern looking. Some of them are, and some of them have serifs and they're old-fashioned looking, and some of them look like script font, like somebody wrote it with a pen, and some of them are funny looking and have personalities. So the ultimate result of this is that typography has taken on a variety of different histories and aesthetics from over the years, not just the Swiss style. But the Swiss style is really what moved us into this sort of modernist movement that impacted a lot of design fields, including architecture and art. Now, of course, the hallmarks of this style are asymmetric layouts, use of grid, which is a big part of graphic design, sans serif typefaces, like I said, flush left, ragged right paragraphs. The style is also associated with a preference for photography as in place of using illustrations in the design work. Now, this style was developed by a number of people, but early practitioners of it included Ernst Keller, who is this gentleman over here, and he taught a philosophy of style that dictated that the solution to the design problem should emerge from its content, which basically meant the content you had to put into the thing you were designing, the words you had to put in there, the pictures you had to use should dictate how you design it. So let's look at some of it. So, of course, this typographic style, as you can imagine, also resulted in some brand new typefaces, including this one here. And here's an example of it. Very clean, very modern, sans serif. Here is a poster design done in the Swiss style, this very blocky, clean, flat-looking type. And this one here as well. Now, again, this is an artistic style that data visualization borrowed heavily from in terms of the typography that is commonly used in data visualization. You don't see a lot of fancy looking script font in data visualization because cleanliness and readability is really important in data visualization. So this sort of type style really kind of played a big role in it. Okay, now we get into the two individuals who can cleanly be said are sort of the parents of data visualization. Now, sure, before this we had charts and graphs, obviously dating way back, and we had lots of artistic movements that really contributed to the vocabulary of data visualization, but it really wasn't until these two people that data visualization became data visualization. And one is the teacher, John Wilder Tukey, and then his student, who we'll look at in a minute, is really kind of the one who carried the baton and moved it forward. Now, John Wilder Tukey is not a designer, he's not an artist, he's actually a mathematician. And he developed the FFT algorithm and the box plot. The box plot is a type of graph. We'll see an example of it in a second. Now, Tukey also invented the Tukey range test, named it after himself, the Tukey lambda distribution, and the Tukey test of additivity. He loved naming things after himself, apparently. He also is credited with coming up with the term bit. And so Tukey was born in New Bedford, Massachusetts in 1915, and he he went to school at Brown University, where he received his master's in science, and then he moved to Princeton University, where he received his PhD in mathematics. Like I say, he was a mathematician, not an artist, not a designer, but of course, data visualization is both equal parts mathematics and equal parts design. He retired in 1985 and died in 2000, so he is pretty current. In descriptive statistics, a box plot is a method for graphically depicting groups of numerical data through their quantity. So let's take a look at some of the stuff he invented. And first of all, let's see a couple of his quotes. So he said, an approximate answer to the right problem is worth a good deal more than the exact answer to an approximate problem. It's a very similar quote to what we just heard from from Otto Neuwirth, right, with regards to his pictograms. Similar perspective on things. The greatest value of a picture is when it forces us to notice what we never expected to see, and there is no data that can be displayed in a pie chart that cannot be better displayed in some other type of chart. So he was not a fan of the pie chart. But that being said, these quotes from Tukey really are sort of the basic tenets of good data visualization, and a lot of this philosophy carries through today. Now, there's nothing wrong with pie charts, but essentially what we can extrapolate from this is that good data visualization should, of course, strive to be more visually engaging than that. This is a box plot, and which is ironic because they're not particularly visually engaging, but they are interesting, and they do a really great job at sort of depicting data over sort of large areas, as it were. These are some more box plots. These are Tukey's box plots specifically. These are the ones he invented and published. Now, Tukey had a student. When Tukey was a teacher, when he was getting his master's degree and his PhD, he had the opportunity to teach, and one of his students was this guy, Edward Tufte. So Edward Rolfe Tufte is an American statistician and professor emeritus of political science, statistics, and computer science at Yale University. He is currently considered basically the father of modern data visualization, and I often say that that is because he is the only one left alive. Of all the people that we have covered so far who were involved in these various movements and data visualization steps forward through history, none of them are alive except for Edward Tufte, and so he gets to be the point person in the world of data visualization. So while he was at Princeton in 1975, he was asked to teach a statistics course to a group of visiting journalists. So these journalists were writing stories about Princeton University and about statistics as an area of study and practice. And so the school went to Tufte and basically said, would you teach this class to these journalists, just to, show them what they want to see, right? And so in this way, Tufte became almost the accidental father of data visualization. So remember, he was a student of Tukey's, so he knew all about Tukey's philosophy and whatnot. And so Tufte put together a set of readings and lectures and statistical graphics, which he developed into seminars. And of course, he went to his teacher and mentor, John Tukey, and said, can you help me out with this? And Tukey helped him develop these seminars. And the course materials became the foundation later for his first book on information design called The Visual Display of Quantitative Information, which that book alone is sort of the birthplace of modern data visualization. Now, if we can unpack this for a second, while Tufte is clearly a brilliant political scientist, statistician, and computer science person, he did not set out to be a data visualization person. He was interested in it because Tukey, his teacher and one of his mentors, was interested in it. But he was asked to teach this class to these journalists. Well, the class went really well. The journalists wrote wonderful things about it, as well as Princeton University and data visualization in general. And so Tufte, not being a fool, ran with it. He took the information that he and Tukey developed together for these seminars and classes, and he wrote a book out of it. And then the book became a bestseller. So this book, The Visual Display of Quantitative Information, became a commercial success. It sold really well. It ended up on the New York Times bestseller list. And it really moved him from the area of political science, which he was really studying and becoming an expert in, to information expert. And so this changed the course of his career forever and planted him firmly as sort of the front runner in the world of data visualization. And so he has written many other books about data visualization. He gives a lot of talks and tours. He comes around often and runs workshops still to this day. In 2010, he was appointed by the Obama administration to work on the American Recovery and Reinvestment Act as an independent advisor to provide transparency in the use of recovery-related funds and to develop data visualizations and data tracking that would show where people's tax dollars were going in this Recovery and Reinvestment Act that was happening, where roads and highways and all sorts of things were being rebuilt. You can learn a lot about Edward Tufte. He has his own webpage. He is available on YouTube, naturally. But here are some of the book covers. So this is the very first book that he wrote that was based on those courses and seminars that he taught to those journalists, The Visual Display of Quantitative Information. This is his other book, Beautiful Evidence, and another one of his books, Visual Explanations. And so, Tufte really becomes kind of the standard bearer for the world of data visualization. And so if modern data visualization has gained anything from Tufte, it is an engaged and intelligent person who wants to promote the act and study of data visualization. And so that's where we are with the history. Now, he brings us up to modern times because, like I said, he's still alive. There are obviously modern practitioners of data visualization. There are people pushing forward the idea of interactive data visualization, and so the history of it is continuing to be written, but this brings us up to modern times. Okay, so that is your very quick 2-week overview of a couple of hundred years of the history of data visualization. So your job is to choose one of those areas from the table of contents, from the list of places that we went through historically originally. Let's click through really quickly. So from this list, you pick one of these areas that you are most interested in, and that's what you're going to do your research and inquiry project on. Now, let's take a look at the research and inquiry project because part 1 is due at the end of this week. Now, part 1 involves this right here. So here's the handout, and obviously you can find it in Canvas under Assignments. So you're going to choose one of the areas covered in our brief history that you're most interested in. You're going to conduct background research on that topic and time frame. Now, if you remember from your FYI class, you did a research and inquiry project there. The structure of this research and inquiry project is almost exactly the same. So you should be familiar with terms like background research and inquiry question. But if not, this handout goes into a great amount of detail about how to do that. So I'm obviously not going to read through it here, but you are going to read through it on your own to understand it. So the first thing you're going to do this week is conduct some background research on the topic and time frame from this list that you have chosen. Get to know as much about it as you can in sort of a broad general sense. Find a whole bunch of resources. Make sure you jot down what your resources are because you are going to have to cite all of your sources at the end. Look to get some more depth and detail on the subject matter beyond, the couple of paragraphs of information that we just covered over the past couple of weeks. And then from your background research, you are going to develop an inquiry question that you would like to pursue further. Now, of course, inquiry questions are questions that you are going to try to answer through the process of this project. You will create the data visualization poster at the end of the project that will show all of your findings. But for right now, we just need their inquiry question. So again, part 1 right here is due at the end of this week. So you're going to conduct your background research. You're going to give us a list of the sources for your background research, and you're going to write an inquiry question. Now, of course, part 1 goes into more detail here, and then this you're going to read through on your own, okay? Now, the writing of the inquiry question cannot happen until you've finished your background research. So get to know as much about your subject as you can, broadly speaking. You'll have a chance to get into more detail later. You can research sources from the library, from the internet. Make sure you're using reliable sources, things that can be cited, journals, reputable news locations, academic citations, those sorts of things. Your inquiry question can be about one or more people, a place, a political, historical, or social movement, or pretty much anything that you find interesting about those periods of time and those areas of data visualization history that we covered. If you are unsure of how to write a good inquiry question, there is a section a few pages down from here entitled How to Write Your Inquiry Research Question. So go read through that, and that'll help you figure out how to actually write the question itself. Okay, but here's some sample questions. How did Florence Nightingale's Rose diagram help to save lives? How were African Americans viewed scientifically and socially in the United States following the Emancipation Proclamation? That relates to the efforts of W.B. Du Bois. How did the Bauhaus influence art and design education in the United States in the 20th and 21st centuries? So those are examples of good inquiry questions. You could steal any of those if you would like, but only if you really, really love it. If you don't love it, go write your own question. Go pick your own time frame, okay? And again, we're going to try to stick to the how to write your inquiry question. So you can jump ahead a couple pages and figure that out. But you can see by these examples how they're basically structured. Now, we are going to try to not have duplicates in class. It says no duplicate questions, please. I'd like each person to have their own unique question. But we'll manage that as we go along. So don't worry about it right now. For now, pick your time frame that you want to study, do your background research, and write your inquiry question. And make sure you turn that in by the end of this week. All right, so that's it for now. Go get to work. If you need me, you know where to find me. Remember, we've got our office hours Mondays and Fridays on Zoom. Other than that, you can email me, and I will see you soon.